let's go. So yeah, so when preparing this panel, I read into like the blockchain trilemma, which basically says that a system can only solve two of decentralization, security, and scalability. And so Ethereum L1 successfully solved decentralization and security. And obviously, we are now looking to go to this scalability stage. And so this evening, we have Declan from Consensus Linea and Tom from Starknet, who are working on L2s and ZK-EVM, trying to work towards solving this scalability. So maybe to start, maybe to you, Declan, at a high level, can you remind what L2s are, how they help scaling Ethereum? Maybe what are the types of L2? So we heard about optimistic and ZK now, and maybe commenting why ZK would be superior to optimistic.
Yeah, sure. So layer 2, basically what we're doing is we are taking the execution that previously was on Ethereum, and we're moving it to another layer. So we're sort of abstractly saying that it's a layer 2. What we can do there is we can basically batch many transactions together with sort of different assumptions. So we can batch them. We can then submit a batch of transactions in a sort of succinct and compressed way to Ethereum, which then is settled and has the data available. So what this does, in effect, is it allows us to scale execution. This means we can have many more transactions at a lower gas price, but we're not actually sacrificing, like you said, the security and decentralization of Ethereum itself. The cool thing about rollups, I guess, compared to some of the previous scaling solutions as we were looking to sort of scale Ethereum, is you actually get your security and liveness from the layer 1 itself. So as a user, you know that if for whatever instance the rollup, which is a sort of off-chain system, if it goes, becomes unavailable or decides to censor you, you can always actually use the L1 to therefore withdraw your funds. So your actual assumptions of security and liveness can come through the L1 itself. So that is the real power of rollups compared to some of the previous scaling solutions we had, like Plasma, for example, or I guess sidechains. In terms of those like rollups, there are two, I guess, popular solutions: optimistic and ZK. Optimistic was probably the first, the first ones to kind of move to mainnet and help to scale Ethereum. With an optimistic rollup, you're basically optimistically assuming that this computation done in an off-chain system is in fact valid. Okay, it's almost like innocent until proven guilty. So what you do there is when you actually send a commitment of the state to Ethereum, you're basically you're waiting for a third party to detect and report fraud, which is why you have this 7-day challenge window. With a ZK rollup, it's quite a different assumption. You're basically almost like pessimistically assuming that the computation done off-chain is not actually valid. So you send a commitment to Ethereum, and then you follow it up with what we call a validity proof, or a ZK proof, I suppose. And that's why you get much faster finality with a ZK of an optimistic rollup.
Thank you so much, Declan. Tom, maybe, so what was important for you when you designed Starknet?
Okay, so maybe a word about Starknet before.
Yeah.
So first of all, nice to meet you, everyone. So Starknet is an L2 validity rollup on top of Ethereum. It's not a ZK-EVM, right? What it means that Linea implements, you would tell after that how exactly, but the EVM and proves the execution of the EVM, and Starknet choose a different route. And we have our own VM and our own language. It's called Cairo. And basically, smart contracts on Starknet are written in Cairo. But the same principle that Declan described also applies to Starknet. So batches of blocks of transactions are being proven off on L2 and then being verified on L1. And when you ask what I had, we did some different choices than other validity rollups that exist out there. I think the main at least goal for me or the goal for us there were few. But basically, if we're building a scaling infrastructure that hopefully is supposed to serve mass adoption, then we didn't want to we wanted to maximize for performance from the get-go. And this was one of the main choices why we chose Starks, which are the technology for the proofs that we are using, and why we chose our Cairo VM, which is a VM or a language that was specifically designed to be the most efficient way to generate proofs. So this was one of the, and this is true for many, many choices along the way in the design. It has trade-offs, but I think in the long run, so this was one of the ideas at least.
Okay. Thank you so much, Tom. So maybe diving into it, EVM equivalence. So you said that you built Starknet to maximize performances, but not being EVM compatible from scratch. On your side, Declan, with Consensus Linea, you are building what we name a Type 2 ZK-EVM. So could you please explain what is a Type 2 ZK-EVM and what are the advantages for such an approach?
Yeah, sure. So I think we've kind of settled that rollups are the best scaling solution. I think we'd agree, especially in this panel, that like ZK or Validity rollups are the best in terms of optimistic VCK. But then it comes down to like your execution environment, your virtual machine. Our approach was we wanted to extend the network effects of Ethereum, of the EVM, all that infrastructure, that ecosystem, the tooling, the dApps. So we wanted to make sure that Linea was as compatible as possible, as makes sense in this current day. So we actually have what is a Type 2 ZK-EVM. So just sort of, I guess, broadly speaking about the different types, I'd say there's really mostly it's Type 4 ZK-EVM, which is sort of like EVM compatible. You won't have the same compiler as Ethereum, so you won't use a Sol C compiler. Your interface won't necessarily be matching the JSON RPC interface if you're a developer. Whereas if you have a Type 2 ZK-EVM, all of that experience as a developer and tooling is exactly the same. So that's really great practically, because if you have a dApp on Ethereum and you're looking to like move to a more scalable layer, you can just take that same application and just port it over, which is awesome. All the tools that you're already familiar with just work out of the box. And then also from like a decentralization perspective, there's no sort of, I guess, like vendor lock-in in a way, because you know, there are many EVM chains. If you come to Linea and you, for whatever reason, don't like it, or you still want to like go multi-chain, then you effectively can do that. We're not like keeping you inside. So that is the sort of promise of a Type 2 ZK-EVM. There is another type, which is the Type 1 ZK-EVM. So this is actually what we would say is Ethereum equivalent. And this is sort of a longer-term goal for Linea, where you can actually then take that to the Ethereum layer itself, the layer 1, and ultimately approve Ethereum blocks. So it actually has the same internal structure as Ethereum.
Thank you, Declan. So maybe speaking a bit about scalability and performances then, which is like often the hot topic. Maybe first thing is when we speak about performances, we need to be able to kind of compare apples to apples.
Yeah.
And so maybe just, would you like to speak a bit about like what are your approach for measuring performances? Like what are the types of metrics that you measure? What type of transactions you are benchmarking against? Because yeah,
it's a good question. So I can speak for myself or for Starknet. I don't think we have some way to measure really performance across different L2s, because there are many, many metrics. What's the throughput? What's the finality? What's the cost? And then when you're trying to, okay, let's say I proved, I don't know, 1K swaps. So what exactly are those swaps? I mean, is it the same state structure? So there are many things. But when we try, I mean, currently we had like a big focus to improve the performance of the sequencer of Starknet. This was a major milestone for Starknet last week. And there you have like a concrete metrics of transfers per second, right? This was one of the things that we tried to optimize for. More broadly speaking, the equivalence of gas for Starknet is what we called Cairo steps. and this is a bit more granular way of defining benchmarks, because it doesn't necessarily talks about a specific type of transaction, but on a general, what's the amount of computation that you are able to process and then prove. Now, the funny thing is that on Starknet, currently the prover is far from being the bottleneck. I mean, the throughput or the capacity that the provers can handle is an order of magnitude more than what the sequencer. So the sequencer is the bottleneck, and it makes sense in a way because the sequencer is sequential, right? It must go through the execution in a sequential way. And the nice thing about proving, specifically when we have recursion, is that everything can be parallelized, right? So right now the focus is to improve the benchmarks or the throughput of the sequencer, mainly for us. I hope it answered the question.
Thank you, Tom. Maybe Declan, do you want to add something?
Yeah, I think it's a great point. I would echo that. I think the prover is it's definitely not a bottleneck. Even for ourselves, there is still the fact that many execution clients can't take a lot of load, especially when you're dealing with the EVM. So it's for someone like Linea, where we're trying to emulate the EVM with a ZK-EVM, we're thinking a lot about how to increase the throughput as well. So we're quite fortunate as part of Consensus that we work very closely with the Besu team. So Besu is one of the execution clients of Ethereum itself. So we're actually working very closely with that team to increase the throughput. Like even just today, it's we have sort of 12-second blocks, 30 million gas. It's a start, but we want to get that down to 3-second, 1-second blocks, again at 30 million gas. So allowing us to increase the throughput in the short term to deal with hopefully these new Web3 use cases, which are going to ask for more demand, ask for more block space, because I don't see the prover being a bottleneck for those use cases. Also in terms of like cost, as you mentioned, you can sort of measure performance in many different ways. So not just throughput, but like actually how much is it costing users to transact? How long does it take to actually get a certain level of finality if you're using an L2 like Linea or Starknet? So yeah, definitely would love to see some more like standardization or way that people could actually look at these systems and almost compare apples with apples. Like it's not there today. Yeah.
Thank you. Maybe moving to the next topic. So one of those blockchain trilemmas is security. So when it comes to ZK Rollups, what should be the key consideration when it comes to security?
There are a few. I mean, the key consideration, I think that with all of those systems, you basically have some technological risk, right? You're pushing the technology to the edge. From that, and from our perspective, it's like the validity proof technology, which is, I would say, quite young. And in that sense, there is a huge benefit to a well battle-tested stack and a simple stack, right? So Starknet is based on Starks, as I've said, and it uses the same technology that we are using in production for the past, on mainnet for the past 3 years already, which I think it's close to facilitate $1 trillion of trades and transfers on Ethereum. And also the simplicity of the Stark system in itself. I mean, the cryptography assumptions, to put it in simple words, what do you assume to work in order for this system to be safe is the minimal from all other proof systems that exist. And it's also very easy to reason about it. I mean, Starknet is basically a program written in Cairo, right? There's no fancy cryptography or anything like that you will find it hard to audit. I mean, Starknet is a Cairo program, and the Cairo, I mean, it's a very well-defined way that we prove it using Starks. So to me, this is one of the key considerations, specifically for those validity rollups that use this type of technology.
Yeah, I agree. I think, especially for like ZK or validity rollups, it is a new technology. I think it's important when thinking about these constraint systems in the circuit, how do we actually make sure the specification, is battle tested or is peer reviewed and audited? Something that we thought about this a lot at Linea, and we actually published a 150-page specification of our ZK-EVM. which is a way to sort of help the community have more eyes on it, to understand it, peer review it, try and catch any issues with the spec, because it's very difficult to make the EVM in a constraint system, as we take literally the execution trace of an Ethereum or sort of an EVM block, and then feed that directly into the prover, into the constraint system, so there's no intermediate mapping, which is extremely challenging to create a constraint system. I think that being said, because the EVM continues to evolve, it's almost like a lot of these teams that are building these systems are going to have to continuously update their spec and their implementation. So something that we are quite optimistic about is this idea of the multi-prover for a ZK-EVM. So you can actually have your transaction and your batch being proven by multiple diverse implementations of a prover of a ZK-EVM. And that basically means that as long as you have quorum on the L1 consensus that like if there's 3, then 2 of them are valid. If there's a bug in one of the circuits, you're still safe. Like it's not a catastrophic game over. It's the same sort of client diversity that you get from Ethereum by having many different execution and consensus clients. So that's sort of a mid to long-term goal when these systems get more performant and we can actually say, right, let's have 3 validity proofs for each block. It can also allow us to maybe experiment with more systems as well because we can put it on mainnet as long as there's enough of these other solutions that are more battle tested. So I think there are these security and risk assumptions, but we have an idea on the roadmap of like how to overcome them in time.
Thank you. So yes, indeed, I was going to ask about client diversity, and you already mentioned it. So maybe like indeed to reach this client diversity, we need open sourcing at least part of the system. You mentioned the specs, for example. So a question more broadly around open sourcing. So how are you addressing, what's your open source like path forward and where you are today, maybe with Linea and then Tom, if you want to comment for Stanley.
Yeah, go first. So Linea launched its mainnet to the public this week. It's still not open source yet. We're working on that. We committed to making it open source. It will be a GPL3 license, hopefully getting that published in the next month or 2. Just going through some more, getting some more eyes on that, on the software. We're committed to open source, decentralization, trustlessness, so it's going to, all of the software that we're building is going to be that same way. It's going to be at least copyleft, if not permissive, to allow people to take this, to be able to instantiate their own linear chain if they so wish. That's something that we believe is important. And we don't want to create any sort of like closed system on the open source side. And all our previous, I guess, products and projects or consensus have been open source in terms of the research side. Like we maintain many public goods, Besu, Teku, Web3 Signer, Ganark as well, which is one of the popular crypto libraries coming out. So yeah, everything we do is pretty much in the open, and like that's just the way that we think things should be done.
Tom, do you want to comment?
Yeah, I fully agree. One thing, even before that, on client diversity. So, I mean, one of the nicest things about Starknet is the community and the ecosystem, which is really amazing, and also from the core infrastructure pieces that you have in the network. So even though the network is quite young, you have on each level of this core infrastructure a few teams that are building and implementing. So for example, sequencers, there's the sequencer that is now running, but there are 2 other efforts to build a sequencer for the network. For the prover, the same. There is our sequencer, Starknet, that has been running for years now, but an effort by Lambda class and an effort, another one which is called Sandstorm, to build provers for the network. Same for the full nodes. There are 3 implementations of a full node for Starknet. Yeah, and all of them are open source. So I think that, at least in my opinion, I don't see a difference. I mean, I think that also for L2, you must have client diversity throughout the infrastructure of the network.
So is the idea of that then that the best implementation of the sequencer, you'd have that in the system, or like is?
No, the idea is, I mean, Starknet will have a permissionless set of sequencers. Okay. So the idea, so anyone will be able to use whatever they want. There is a question on what will be, I mean, will we be limited by the least performance sequencer or something like that? But Yeah, the idea for me is that there will be few sequences running, and this way you ensure the liveness of the system even if one of the implementations fail.
Okay. That's cool.
Same for prover, same for full nodes.
Yeah.
Thank you. Maybe like a last topic that we can address is around, so how do we build such systems? So obviously ZK Rollups are basically at the top of innovation, relying on some of the latest research that we have. And so maybe interested in understanding how your team are organized to be able to ship, build such type of software.
Yeah, so, I mean, fortunately, I'm blessed to work with really amazing people, and specifically, I mean, the inventors of Snarks and Starks are working at Starkware, and I'm working on Starknet. So this is, you know, the first blessing that we have, and also, I mean, I think 80% probably of Starkware are engineers, and the best that I know, like with deep knowledge of both programming and making systems, but also mathematics and the research around Starks and cryptography in general. And I mean, to me, as the product lead of Starknet, it is good and challenging, but it's in general, it's amazing for Starknet. So that's what you ask, right?
Yeah, speaking about your team, like, thank you, Tom.
Yeah.
And maybe Declan, you.
Yeah, I think similar for us. You know, a lot of the team has been with Consensus for a long time as part of the R&D. This project for Linea started January 2019, so like, you know, four years ago, when a lot of people were saying, oh, let's focus on optimistic solutions or let's focus on ZK, but people didn't think it'd be possible to, you know, I guess, take the EVM and put it in a circuit. So went down the route more of like building a specialized VM as well. So that's been a sort of long journey for the team, and a lot of people have been spending, you know, years on this sort of research problem. I think we're also quite fortunate as well to be part of Consensus to actually think more about, you know, what it takes for developers and these ecosystems to be successful. Like, it's not just having, you know, great infrastructure and great research and having these proving systems that can do a lot of processing in an efficient way, but also, you know, actually the stability of the network, the need for throughput that we mentioned earlier, the also need for developers to access like a mass audience. So being able, for example, with Consensus and Linea, actually being able to have this distribution for a dApp to go through the MetaMask wallet is something that's really powerful, because it's not just about the technological side, it's about getting product market fit, getting to users. So we're lucky to have a team that kind of considers the whole, I guess, developer journey, which is, yeah, I think something that's quite unique about Linea.
Thank you so much, Declan. Thank you so much, Tom. I think I'm done with my questions for you today, but maybe we can take a few minutes more to hear some questions from the audience, if any. Yes, please. Maybe if you have a mic.
So yeah, I don't know if it's relevant, but earlier today we had a presentation that talked about zero knowledge proof being implemented in layer 1 of Ethereum directly. Once and eventually, when this is implemented, like, would it have any impact on what you guys are working on, if any? And do you have any take on this, more broadly speaking?
I mean, for us, that is an end goal as well. Like, we are working towards being able to have a system that can prove Ethereum blocks directly. So the journey for us is, you know, like I said earlier, like type 2 ZK-EVM, we basically are exactly the same structure as Ethereum itself, apart from the internal state. The block structure, we don't use Ketchak for that. We don't use the Patricia Merkle tree. We have a different system. But as performance has improved and this technology gets better, it won't be long before the state structure looks exactly the same, and we can drop that into Ethereum. If other teams are doing the same thing as well, like the EF and other ZK VMs, then that's good, because we don't want to have put all our eggs in one basket. Like again, we need diversity. You know, if each of these execution shards on Ethereum are like a different implementation of a ZK-EVM, then that's actually better because we're not limiting ourselves to one design.
Yeah. I mean, the end goal is to scale blockchains. So, and I mean, it was also talked in few places. You said it was talked by Vitalik?
Yeah, it was mentioned earlier today. Yeah.
Okay. Anyway, so I think that, I mean, in my opinion, it should be done, and also it should adopt Cairo. So yeah, that's my that's my goal.
Any other question?
You had a question.
Yeah, you were mentioning distributed sequencing.
Just one second.
You were mentioning, Tom, distributed sequencing, and my question was for you, Declan, for Linea. What is the current implementation of sequencers, and do you have in mind some changes for the future?
Yeah, so today, like obviously just launching mainnet, it's an alpha. The system is still somewhat centralized, as pretty much every rollup is today. So like the sequencer and the prover is being run and operated by consensus. That is not the goal. We want to decentralize both of those operators and the governance side as well. We also released a decentralization roadmap as part of our launch to kind of outlay the different steps that we need to take to get there. It's not an easy problem to solve, which is probably why most teams haven't done it yet. I don't think you can just take the existing assumptions of Ethereum, for example, like proof of stake, and slap that on L2 and expect it to play out the same way. There's like different forces, such as liquid staking tokens that can lead to centralization around where the stake actually ends up. And then so how, from a governance perspective, do you best manage a system like that on L2 rather than L1? L1 has the benefit of ETH being money, but L2, we use ETH as the native gas currency as well, and that's how we continue to operate. So it's a very hard problem to decentralize. We will decentralize and kind of looking to work more with the community and all the researchers on Linea to kind of figure out the best way to do it.
Thanks a lot, guys. I just want to say...